One of the first consequences of the Earth's climate getting hotter is that we have what are called extreme weather events. And I think, again, you'll know how to measure those. It's in terms of droughts, it's in terms of hurricanes, enormous storms, flooding. And there's been records over recent times of these sorts of events. And here I show you the recorded numbers of extreme weather events. And here you can see the number steadily increasing again. And these are things like, these are storms, these are flooding, and this is extreme droughts, right? Extreme temperature excursions. So when the temperature goes up, it doesn't always actually go up, but there are lots of wobbles around it. And these are the wobbles that cause these rather extreme weather events. So it was always predicted to be the first sign of global warming, but now you actually observe it. It's recorded. I just show you this. This is a photograph, an aerial photograph from about 2 years ago, just over 2 years ago in Britain, in Somerset. And these are normally all fields, and they're completely covered in a flood. It's in Somerset, in the west of England. And I should add, these are not the preparations for planting rice, right? But we don't do that so much in Britain because it doesn't get warm enough. But this was completely pasture land, green normally, completely flooded. And it was one of the biggest floods we've had for a long while. But in other parts of Britain today, recently, there have been massive flooding as well in the northwest and the west parts of particularly of England and of Scotland. So these are the physical manifestations, if you want, of what this climate change will do for you. And here you see again the projections of what's going to happen, depending on the amount of the black lines of various models of greenhouse gas emissions. And you can see that to keep a temperature increase down in these boundaries of 2.4 degrees, 1.5 to 2.5 degrees centigrade, you've got to stay in this range here. And that means your emissions have got to stabilize and start to come down. If they don't, the temperature is just going to go up. All those people that want all that extra energy, if it comes from burning fossil fuels, is going to push this up further so that we get a higher temperature increase and more extreme weather events and more main problems associated with them. So the world has got, if we're going to be at all successful, has got to cut down on this carbon emission. Otherwise, we haven't got a chance. But what I'm going to try and show you is that we know a lot about that and that there is a lot of possibilities for being able to get to grips with it. And it was starting to be getting to grips with in Paris before Christmas at this conference, which all of the countries of the world, save for two, I think, agreed that they would try to limit carbon emissions so that the warming could be kept to between 1.5 and 2 degrees centigrade in the terms that I've been talking about. This was a great event. The previous meetings of this had been in Copenhagen, and I think 6 years ago, and it had been a complete disaster. Nobody could agree on anything. But I think what's happening in terms is becoming so self-evident to people that they've got to do something about it. We've all got to do something about it. And even what I find reassuring is that even businesses start to think they've got to do something about it because they've concluded that the cost of not doing anything will be greater than the cost of doing something if we just left things to move on. But it's going to be a tough business to get there. How are we going to do it? So here's a little prescription for you. It's all in one slide. It must therefore be very easy. But of course it isn't. First of all, we've got to cut back on our energy demands. And I'm going to give you some examples of how one does that and where it has been effective. We've got to get rid of fossil fuels because they are a complete mess. They're the problem that we're going to live with and future generations are going to live with. And I'm not talking about my generation. I'm not even talking about your generation for many of you out there. I'm talking about your children's generations because these things last for 50 or 60, 70, 80 years. So we've got a responsibility to do something about it. Now, what can we do? Well, there are only two real things that we can do, besides reducing our demand, is to go to renewables, and that means use solar, wind, and I'll deal with these, geothermal, hydro, wave, and tidal sources. The ones that are the lead ones clearly are solar and wind, and also hydro sources, hydrological sources. And then to turn also to nuclear power, which has the ability to give you lots of energy using slow and fast fission reactors and possibly fusion reactors. And I'll talk about those as the nuclear energy content of this at the end. Now, what I want to make clear is there is no one answer. The answer is going to be different where you are in the world. And also what day of the year it is in the world, because I think you'd all agree that you wouldn't have got a lot of solar power in the last 2 or 3 days, even in Hong Kong, because I don't think I saw the sun since I arrived here in Hong Kong. But there are lots of places that have that same problem. But everywhere will have its different. In Britain, we don't see much sun, but we do have wind. So wind will be an important thing in going forward. But there are difficulties with renewables, which I'll return to, particularly the fact that they're intermittent. And one thing that is not intermittent is the energy you get out of nuclear power reactors, and that's why I think they have to play an important role in the future. So that's how you solve this problem, but I want to go into that in a bit more detail now. So, plans for primary energy. Well, what were those plans that I was talking about in these projections going up to 2030, 2035? That was the composition of where we got our primary energy from, liquids being gas often, and natural gas, and this is oil, coal you see there. Here are the renewables and the nuclear, up until 2008. If you then play that on as to what the projections were going to be to get up to that date of 2035, you actually find that in this, the renewables are tripling. That was the projections. The nuclear was in fact doubling. But of course, everything else, although these were going a bit faster than these, they were still the dominant things. And that was the thing I pointed out to you earlier, that we weren't getting away from fossil fuels. So that's what we were going to do to get hold of the energy. So that's the first thing, and we know we've got to get rid of that CO2, so we'll come back to the solutions to that in a little while. Now, the use of energy, I found what I'm about to show you very interesting, and I'm going to use the UK, as where I know best, as an example of how you use energy. It'll be different in different parts of the world, but the same stories will apply. I found this plot as to the way we were using energy very, very interesting. Here we are in 1970, and here's 2015. Now, what I want you to draw your attention to in this plot is that here we see a big decline in Britain in the energy used for industry. Now, we know why that is. That's not because we got more efficient. It's because actually we stopped making things in Britain and we expected the Chinese and the Indians to make them. So our power consumption for industry went down. But of course, that wasn't stopping CO2 being emitted because the Chinese, the Indians, and any other place where we exported the industry to actually were producing that CO2. So it looks good that we've dropped our energy consumption, but it's almost balanced by an increase in transport, this blue line. And that's the cars, the aeroplanes, everything else, the ships that we use. And it has gone up over that time by almost a factor of 2. And it sort of compensates this decline. This goes up by a factor of 2. I found that very interesting. But you know the solution to that. Those of you who remember, I suspect Hong Kong was like it in 1970. There were nowhere near as many cars here. In Britain, it was not common for almost everybody to have a car. They do have a car nowadays to be able to get about. That's where that increase, that change in style of living. But what also is interesting here is the homes here. This is the energy used in homes for heating, for cooking, for lighting, for whatever. And that, surprisingly, has stayed almost constant over that period of time. And that despite the fact that we've had about a 20% increase in our population in Britain over that time. So that actually represents a tremendous efficiency. It also, improving in efficiency, it also represents the importance of regulation, of regulators coming in and checking on house insulation in our case, because it's a cold country, and things and how dishwashers, washing machines, how efficient they are and how much power they use, and regulating that. So this is, I think, again, fascinating over that period of time. So when you look, and you look at this in a slightly different way, you see that Britain has not changed its power consumption in the last 40 years, despite having an increased population. And the important thing you see here is this issue of travel. And of course, I'm contributing to this here because I flew here in an aeroplane. So the amount of plane travel has gone up immensely in that time. And here you can see the amount of energy expended on road. And remember, this is during a period where every manufacturer this has been achieved by having already great improvements in engine efficiencies in automobiles and in aeroplanes. They go much further for a gallon of gas these days. So we've been working hard, in a sense, to stand still. So we've therefore got to face up to what we're going to do in the next 20 years even to get to a reasonable place in 2035. The first thing you can conclude, if you have a hope to cut down CO2 emission, you've got to move transport away from fossil fuels. After all, they run on gas or oil or derivatives of them. So they are major contributors to this CO2 and nitrous oxide emissions. So you've got to move them away. I'm not quite sure where you move them to do, but I'm sure you're going to need lots more electricity for it if you go to electric cars, or more progressively more and more hybrid cars, or perhaps even to a hydrogen economy. But that's a bit tough to introduce. Even if you did introduce hydrogen, you'd need electricity to make the hydrogen, to do the electrolysis, to get you the hydrogen. So these imply more electricity. And the other issue is that they all require storage. You have to be able to store that energy, and we aren't good at storage yet. So there's a lot of simple technical, engineering, scientific activities that have got to be cracked to move us forward. And then electricity, if you get this electricity, you've got to move electricity generation, has got to be moved away from fossil fuels. You've got to get rid of them. And unfortunately, that means going to those renewables. And there, the intermittency that I talked about, the fact the wind doesn't blow or the sun doesn't shine, you have to be able to cope with that. And that means you have to have backups to those renewable systems, which means more investment in capital plant, and storage. So storage, again, is a theme that's always here. If we want to go forward, we've got to develop and got better storage systems.